Hello Math 2 students, this video is going to help you construct an equilateral triangle, an isosceles triangle, a right isosceles triangle. You're also going to be able to circumscribe a circle around the outside of a triangle. And finally, we're going to learn how to figure out which angle is bigger by looking at the sides of a triangle and which side is bigger by looking at the angles of a triangle. All right, get out your notes and get ready to learn about constructing triangles. On this problem, we're going to construct an equilateral triangle. Notice that an equilateral triangle has 3 congruent sides and 3 60-degree angles, which of course are congruent. Also notice that an equilateral triangle has a line of symmetry from the top straight down to its base. So we're going to make everything on the left side of that line exactly the same as everything on the right side of that line. To begin, we're going to make a line segment of any length. Whatever length this line segment is, that's going to be the length of all 3 sides of our triangle. Now that I have that line segment, I adjust the radius of my compass so that it is exactly that length. Now I'm going to swing an arc from one end of my line segment to where I think the vertex at the top is going to be. So I imagine that the vertex is going to be right here somewhere. Then without changing the radius of my compass, I line it up on the opposite endpoint of my line segment, and the only thing I need is an X at the top that shows me where my vertex is. So now if I connect this vertex at the top with the endpoint of my original segment and the other endpoint of my original segment with that same X that will be the vertex at the top, I have just constructed an equilateral triangle. Every side is exactly the same because I used the same compass radius for every side, and every angle is 60 degrees because the 180 degrees of the triangle is divided evenly 3 ways. On this problem, we will construct an isosceles triangle. An isosceles triangle has 2 congruent sides and 2 congruent angles. Notice that an isosceles triangle also has a line of symmetry that goes from the vertex at the top to the base. And so we want to make everything to the left of that line of symmetry exactly the same as everything to the right of that line of symmetry. So I'm going to start the same way I did on the equilateral triangle by making a line segment of any length. The only difference is now I need to make sure that the radius of my compass is either longer or shorter than that original segment so that I get an isosceles triangle, not an equilateral triangle. So I'm going to make my compass radius a little bigger, and as you can see here, it is longer than the segment that I'm using for the base of my isosceles triangle. I could make it shorter if I wanted to, but on my triangle right now, I'm going to make it longer. So I have my pivot point lined up with one end of my line segment, and I'm going to swing an arc. The only part of the arc that I really need is this part up here where my vertex is going to be at the top. Now, without changing the size of my compass, keeping the radius the same, I put it on the opposite endpoint of my line segment, and I find out where the X is for my vertex. So since the distance from here to this arc is the same radius as from here to this arc, I know that these 2 sides are going to be the same. So if I draw a line segment from that endpoint to the X at the top and the opposite endpoint to the X at the top, I will have an isosceles triangle. These 2 sides are the same and these 2 angles are the same. Next, we are going to construct a right isosceles triangle. And one way to do this is to make a perpendicular bisector construction so that we have a right angle, and then make sure that we have 2 congruent sides of our right triangle by swinging 2 arcs with the same radius. So I'm going to start out with the perpendicular bisector construction so I can have a segment of any length. I put my pivot point on one end of that segment and make sure that the radius is longer than halfway past the midpoint. I swing an arc that is above and below that midpoint and turn my compass around and swing an arc with the same radius above and below. And now this will be my perpendicular bisector. So the right angle is here and my right angle is here. Now I need to make sure that these two legs come out the same on my construction. So I'm going to put my pivot point on the point of intersection. I'm going to adjust my compass so that it is a size that will intersect my original segment. And I'm going to swing an arc here that cuts off a segment. And I'm going to go above the point of intersection and swing the same exact arc. So this distance here is the same as this distance here. And this angle is a 90-degree angle. So now if I connect the 2 points of intersection where my arcs intersected the line segment, this triangle from here to here to here is a right isosceles triangle. Some students like to make a right isosceles triangle by constructing a square and then cutting it in half, because half of a square is a right isosceles triangle. We are going to circumscribe a circle about the given triangle, which means we are going to draw a circle that goes around the outside of the triangle and intersects each vertex of the triangle. In order to do this, we need to find a point to put our compass that will be the center of our circle. And to do that, you need to construct the perpendicular bisector of the sides. So I'm going to start with this side here, and I'm going to do the perpendicular bisector construction. Now I'm going to go to this side, and I'm going to do the perpendicular bisector construction. And my two perpendicular bisectors intersect right here. Now, if I made a perpendicular bisector of this side here, it would cross in this same exact point. So the three perpendicular bisectors of the three sides of a triangle intersect in a concurrent point, which means those three lines will all cross in one place, in exactly one point. And because of that, I don't need to do the third perpendicular bisector construction because I know it would cross right here anyway. Now, that is the point where I need to put my pivot point to construct my circle. So I put the pivot point here, and I set the pencil hole or the radius right on the vertex of the triangle. And I could use any of the three vertexes because when I start to draw this circle, it's going to go through every vertex perfectly. So there you have it. My original triangle is here, and it had 1, 2, 3 vertices. And by using the perpendicular bisector construction on 2 of the sides, or I could do it on all 3 of the sides if I wanted to, I was able to find the point where I should put my pivot point, and here's where I should put my pencil hole, and that gives me the radius of this circle that perfectly intersects all 3 vertices. Have you ever wondered if you could tell which angle of a triangle is going to be bigger just by looking at its sides? Well, the triangle longer side theorem lets you do that. It says if 2 sides of a triangle are different, then the angle opposite the longer side will be larger. So in this picture, if we look at the lengths of the sides, they're measured by arm lengths of this guy. And there's 4 arm lengths here. There's 8 arm lengths here and 8 arm lengths there. So if we take the blue and the green side, they are definitely not the same size. But according to this theorem, it says if we look opposite the longer side, we will find the larger angle. And when we look opposite the blue side, we find a 75-degree angle. And when we look opposite the green side, we find only a 30-degree angle. So the larger angle is opposite the longer side. If we compare the blue and the yellow sides, those sides are both 8 arm lengths long. And if we look at the opposite yellow angle and the opposite blue angle, they're both 75 degrees. So when the sides are not different, the angles will not be different. Now, if you've ever wondered if you can tell which side is longer just by looking at the angles, that's what the triangle larger angle theorem is about. If two angles of a triangle are different, then the side opposite the larger angle will be longer. So if we look at the yellow angle, it's 30 degrees, and the blue angle, it's 126 degrees. When we look opposite the 126-degree angle, the blue side is definitely longer than the yellow side. The blue side is 8 arm lengths long, and the yellow side is only 5 arm lengths long. So the longer side is opposite the larger angle. Now we should be able to look at these three angles, the 62-degree angle, the 73-degree angle, and the 45-degree angle, and we should be able to tell which side of the triangle is longer. So the first comparison that they want us to make is they want us to compare the blue side, AB, to the green side, BC. Well, opposite the blue side is a 45-degree angle, and opposite the green side is a 62-degree angle. So since 62 degrees is larger than 45 degrees, we know that the green side will be longer than the blue side. So the inequality sign should look like that. The next comparison is the blue side, AB, and the yellow side, AC. If we look at the blue side, the angle across from it is 45, and we look at the yellow side, the angle across from it is 73. Since 73 is the larger angle, AC will be the longer side. The third comparison is the green side, BC, and the yellow side, AC. Opposite the green side, we have a 62-degree angle, and opposite the yellow side, we have a 73-degree angle, so the yellow side has to be longer. On this problem, we're going to look at the sides and we're going to try to figure out which angle is larger. So the first comparison is the blue angle to the yellow angle, and the blue angle is across from a side that has 4 arm lengths, and the yellow angle is across from a side that has 3 arm lengths. If we want to know which angle is bigger, the blue angle or the yellow angle, the blue angle will be bigger because it is opposite the longer side. So our inequality will look like that. Our next comparison is the blue side, which is 4, and the green side, which is 4 plus a little bit more right there. So it's a little bit more, 4 plus. So obviously the green side is longer, so the green angle will be larger. So angle F is larger than angle D. And the final comparison is the yellow angle to the green angle. Well, across from the yellow angle, we have 3 arm lengths. And across from the green angle, we have 4 plus arm lengths. So we know the green angle, angle F, must be larger than angle E. After watching this video, I hope you're able to construct triangles, circumscribe a circle about a triangle, and I hope you can look at the sides and tell which angles will be bigger, or look at the angles and tell which sides are going to be bigger. Thanks for watching.